so far we've only looked at this concept of directional flow in a very kind of linear way, meaning we've only really gone horizontally or vertically. Now the thing is, as long as we're using opposite edges, we can make this edge flow go any direction we like. If I just bend this strip of polygons, you can see these opposite edges have now taken on the characteristics of this quad strip. So it stands to reason we can create edge flow in any shape we want, say using the pen tool like this in quad mode, and build any shape we like, and our selections and our knife cuts will always follow this flow because of these opposite edges. And this is very handy when control cutting for subdivision. But what if we want to make this kind of shape inside a mesh that has a very one-directional kind of edge flow? And by this I mean something like this plane. The direction in this plane only moves horizontally and vertically. So say I want to create that shape that I just made with the pen tool, and I want to enter this edge here and exit from this edge here. I can't really do that inside this mesh because obviously my opposite edges are just traveling in one direction. So somewhere inside this mesh, I need to redirect the flow of opposite edges. Now there are a number of techniques available to do this, and we're going to look at these now and see what the pros and cons are of each method. Now before we do this, I want to show you the kind of thing that you don't want to be doing. And in this example you can see that we've taken this row of polygons and conformed it to the shape we want. But to do this we've had to take all these rows beneath it and kind of bunch them up into this area at the bottom. And then we're left with these big wide open spaces here. This is not a good workflow, and there are much more efficient ways of doing this. So this kind of bunching scenario is the kind of thing that you want to be avoiding when modelling. So let's have a look at some of these techniques. So we'll start here with a simple example. I have this piece of geometry here, and on the face of it, this geometry looks like it's changing direction. And visually, you could say that's 100% accurate. But internally, this geometry isn't changing direction at all. Instead, what we have is, again, something very much like our plane, where we have a vertical flow travelling up from this edge to the top, and then another flow travelling from this edge over to the right. Now, ideally, what I'd like to happen is for my knife cut to come into this edge and leave over here. So I need to travel round this corner. So what I'm looking to do is unite these two flows together. Now at the moment the problem edges are this edge here because its opposite edge is here, and this edge here because it's causing the flow to travel in this direction from our start edge. Now we saw in the first video that if we wanted to make an outside edge flow around our shape, we needed to add a third edge to this corner, and then our flow would travel around like so. So essentially what I want to do is take these two edges and collapse them into this corner. Now the best way to do this is to grab your weld tool in point mode. The weld tool is MQ, and then I hold Command on a Mac, Control on a PC, and if ever I say Command and you're on PC, I mean Control. And essentially we just weld the point on the end of our edge here to the corner point, and then to get rid of the triangle we weld this point to the corner point too. So now we have this diagonal edge. Now you might have noticed that we've lost this corner polygon, so anytime you weld something it is a subtractive process. Now the good thing about this is we now have two quads here, and in this quad the opposite edge from this one is now here, and in this quad the opposite edge is now here. So effectively what we have is a system of continuous edges. So now if I cut with my knife tool, you can see it flows around this corner. Now the important thing to take from this is not that this edge cut is going round a corner, it's the fact that we've united two flows together. And we've done this using this weld technique. This is all well and good in a simple example like this, but what happens if we go back to our plane geometry and try this with the weld technique? And let's say I want to start at this edge and move through this geometry and maybe come out of this edge here. So what I would do is go to point mode, get my weld tool, obviously come along to the polygon that I want to change direction in, and let's weld this point to here and this point to here, and then travel down and we'll weld this point here and this point here. And if I go back to edge mode, grab my ring selection tool, you can see that that is essentially mission accomplished. And if I go to polygon mode, you can see that I can select through that selection of polygons due to this change in direction. Now, unfortunately, it's not all good news because I've created these triangles here, and you can see what kind of havoc these triangles play with our selections inside this mesh. It starts to get a little bit random, like so. So ultimately, I'd quite like to get rid of these triangles. I've also created another problem where I have these rather large poles here. Now, this is what I was talking about earlier, and this is a complex pole, and we can see this if we go to modeling, get our mesh checking tab, say enable mesh check, and you can see that complex poles are highlighted in purple. My edge count is set to 6, which is flagging up complex poles with more than 6 sides. And I obviously have 2 of these. And if I was deforming this mesh in any way, these would be classified as potentially dangerous. So ultimately, I would like to get rid of these problems. Now, the best way to get rid of both the triangles and these complex poles would be to dissolve these edges. And if I dissolve, you can see that these problems go away. Now I have a problem, though, that my mesh has become slightly uneven in quite a lot of places. Now again, if this geometry was being deformed or curved in some way, and I remove this kind of supportive geometry, I would start to get noticeable deformations in my geometry where this supportive geometry is now disappeared. Now, if this area isn't being deformed or there's no curvature on it, this really isn't a big deal at all. And this would actually be a pretty good technique. So we can clearly see that this welding technique is subtractive. And we've lost quite a few polygons here. We should have 64 polygons on an 8x8 grid. Now we have 51. So how can we do this without losing any geometry? Well, there is a tool in Cinema 4D whose sole purpose is to create this kind of flow inside geometry, and that tool is called the Spin Edge tool. Now, essentially what the Spin Edge tool does is it redistributes the opposite edges of quad polygons. Now, you'll find the Spin Edge tool up in Mesh under Commands, and you can see this here, Spin Edge. And I have mine docked down in a palette down here. So let's say we want to follow the same path that we did before. We want to kind of get to here and then travel along down here. So what I do is I travel along, and when I get to the polygon, which is here that I want to change direction in, I select the edge and I'm going to spin it. Now, I want you to pay attention to the fact that the opposite edge to this edge in this row is this edge here. And likewise, on the other side, the opposite edge is here. So let's spin this edge. Now, you might think to yourself, Toby, you've just created 2 triangles. Well, I haven't. I've created 2 quads that look like triangles. We have a quad here. We have 1, 2, 3, 4 edges on it. Quad here, 1, 2, 3, 4 edges on it. The most important thing to take from this is the fact that the opposite edges from this edge are now here and here, not here and here. So now what happens is my selection will come through these edges, it will hit this edge, skip these 2 edges, and travel to here, essentially changing direction. And if we move some of these points around, to make these quads more quad-shaped, you can obviously see what's happened. Our flow is essentially now changing direction. Now, if I go to polygon mode, you will notice that we still have 64 polygons. So we haven't removed any geometry from our mesh at all. Now, spin edge isn't foolproof, and we do have a couple of byproducts from this. Obviously, I've created 2 5-sided poles here, and also 2 3-sided poles. And another byproduct of spin edge is that I have this secondary flow moving through this set of opposite edges. I also have something happening here where I have a row shift where the selection is coming out from the 4th polygon along here and leaving at the 3rd, and this can actually be pretty useful. So I've introduced a few different flows into this mesh. The thing about these flows is that they are predictable. If I get my loop tool in polygon mode and just kind of go around this mesh, you can see I'm not getting anything that's really all that weird. There's no like large clusters happening. All I'm doing is selecting opposite edges. So although the flow has changed in various ways inside this mesh, there's nothing completely random about it. So we could try this spin edge technique again to maybe turn direction here. Now the one thing about spin edge is you can do this on various different edges. I could take this edge here and spin this a couple of times, and now my opposite edge to here is here. Or I could take this edge here and spin it, and now the opposite edge of this one is here. So both of those different edges are producing the same kind of directional shift, just kind of in different places. Now this is quite advantageous being able to do this because you can see that one edge is kind of flowing diagonally like this, which is very similar to this row. And one variation of the spin edge is moving kind of in the same direction as this flow. So depending on if you're on a curved surface, you can pick and choose which direction you want to spin in and choose that to match the curvature of your mesh, which will produce less deformations. So I think I'm going to choose this edge. I'm going to point mode and just again rearrange some of these points. Poly mode, loop tool, and now I essentially have the flow that I want. If I select my knife tool, you can see this is cutting down this flow quite nicely. Now, although spin edge does produce poles, they can also be used to move poles to different areas of your mesh that might not be so sensitive. Let's say I select these edges, and now I'm going to grab my edge cut tool. Now what the edge cut tool does is it's kind of an extension of your knife tool, but instead of doing one cut, you can essentially do as many cuts as you want, and you can scale and offset them. And it's an incredibly handy tool to cut edge flow with. So if I just click on the screen, you can see I get 2 cuts, and then I can scale those cuts out or offset them wherever I want them to go. So let's scale these out. Select this inside loop of polygons. Let's go to a perspective mode here. Let's bring my axis back. Let's just turn off my modeling mesh checker, and I could drop these polygons down to make a channel. This is the kind of thing you use flow for inside a mesh. You may want to do paneling, cuts, or something like that. Now the problem with the poles that were created by the spin edge is now I've moved this geometry down. They're residing on the transitional line of this geometry. And if you subdivide this, this pole might cause you some shading errors. So we could try that. And if I go to Groove Shading, you can see that on these poles we're getting these slight kind of lumps here. So ideally we'd like to move these poles off of this transitional line. Now to do this, all I essentially have to do is take one of the edges attached to this pole, say this one, and if I spin it, you can see that the pole no longer exists on this transitional surface. And essentially what's happened is that the pole has been moved away to here. So what I can do is grab my point mode and just kind of move some of these points around a little bit. Kind of make this a little bit nicer to look at. So I could do the same thing with this pole here. So what I might do is spin this edge to remove this pole. This time I'm going to do this with the subdivision on, so you can see how the flow actually moves when I spin the edge. So here we go, let's spin this a couple of times. And obviously you can see that flow changing within the subdivision. And now we have this nice flow moving down this edge. There's not much that I can do about this three-sided pole, but you may find that's actually not so much of a problem. Now, as an example, this works for showing you just how spin edge works. And the truth is that you can move poles off of these kind of areas with beveling, but this can be useful for bringing in secondary flows along your edges, and I'm sure we will be using spin edge a little bit throughout this course. It can solve quite a few problems. In fact, let's have a look at some more examples how spin edge can work for us. When it comes to sensitive geometry under subdivision, there is no more sensitive piece of geometry than a cylinder. If the surface of this cylinder deviates anything from these equally spaced edges, you will get a big lump through them. And one thing that happens when you're modelling is you're doing some cuts and you're cutting down your mesh, kind of maybe, further on up the model. And the cut that you want to make, kind of 99% of the time, just due to Sod's law, will go straight through your cylinder. Now, ideally, you don't want to do that because it will distort the features of this cylindrical shape under subdivision. But what you can actually do is use spin edge to redirect this cut away from this sensitive piece of geometry. So let's say I was going to cut in through this edge here. My cut's hitting the cylinder. Well, I could just come down to here, and before I actually reach the cylinder. So let's spin this edge. So what this enables me to do is make my cut but divert it away from the cylinder. And it can be a good way to run edges off the edge of your model. You could put it into a place where it doesn't really matter if there's another cut. So instead of running it off the edge here, we could essentially re-divert it again. And this time run it off this edge. So this can be incredibly handy. You could also use spin edge to actually divert this edge all the way around this cylinder and back up and cut something else up the other side of your model. Now, in fact, spin edge does one other cool thing of diverting things around cylinders. Let's say we have a cylindrical detail here and we want to convert this into a kind of straight piece of geometry going down. We would probably select some points here, hit T, Shift to flatten these, go to edge mode. Here you can see we have continuous flow going all the way around. Let's select this selection and just extrude this down like so. Now let's say I wanted to cut an edge that went all the way around this circle to protect this outer edge. Now you can see that I've got this edge pole here, and perhaps I want to maintain edge flow all the way around this object. I can't really do that by double clicking because it keeps terminating on these edge poles. So what I would like to do is cut up through here and then cut a loop all the way around here. Trouble is though, that when I do a loop cut here, these opposite edges here are diverting my knife cut straight into this hole. And obviously that's not what I want. I would like this edge to travel up to this edge and round to this edge and then back to this edge and down here. So what I can do with spin edge is to grab the offending edge that's ruining my edge flow and then spin it so the edge is effectively moved, allowing this edge flow to carry through. And on the other side I would do that like so. Now you'll see that I call this the open gate technique, and that's exactly what it's doing. It's essentially opening up a certain kind of flow so I can cut through it. And now in edge mode, if I double click this edge here, you can see I now have continual flow. Now to get rid of this degenerate polygon here, which is kind of folding in on itself on these two edges, all I have to do is grab the edge that I spanned before and just spin it back. Same with the other side. So now I have the same kind of thing, but it's been moved inwards and out of the way of this flow. Now there are certain situations where this does arise and this technique can come in really handy. So put that in the back of your mind. I call that the open gate. So that's a couple examples of spin edge. Now we also have one other technique that we can use to introduce flow into geometry. So if welding is a subtractive method and spin edge is pretty much constant and doesn't change your geometry count, this next technique could be classed as additive. Now if you want to introduce flow into continuous edges, you can do this using the bevel tool. The last two techniques have pretty much used opposite edge flow. So if I grab my path selection tool in edge mode, and I can come down here and just make some sort of path. If I grab my bevel tool and I set my subdivision to 1 and then bevel, you can now see that the edge we beveled has continuous flow. So before, there is no continuous flow here because this edge essentially wants to just keep traveling down here like this. So we've had to manually select this flow in the direction we want to go. Then we can go to the bevel tool and bevel it out. And now the edge we selected is continually selectable. Now in polygon mode, you'll notice we now have 90 polygons, and this is essentially because it's added a polygon either side of this edge. And both of these rows of polygons that it's selected also have continuous edge flow. So that's a couple of different ways that we can redirect the flow of continuous edges and opposite edges. There is one very important flow that we haven't discussed yet though, and that is flow that continuously carries on in a perpetual circle, and these are called edge loops. And that's what we're going to discuss next.